Hello and welcome to another Solana tutorial. Earlier today, I learned how to mint and transfer cNFTs, and now I'm like, well, that can't be too hard to do with a program, so we're gonna find out how difficult it actually is to transfer cNFT with a program. Because Jacob was like, well, we need a reference for that, there is nothing out there, and I'm like, okay, I can do it. But can I? My mind is like, yeah, easy, come on, let's do that. But then, seeing how long it took me to just do a normal transfer, it might be difficult. We'll see, and I take you along with me on that journey. Today we learn how to transfer cNFTs in a Solana program. I mean, transfer and minting would also be interesting, but I think transfer is the more difficult one, so let's start with that. So goal for today, transfer a cNFT from within a program. Now let's talk a little bit first, because obviously cNFTs are not in the state. We learned that. Don't put it in the state, just put it in the ledger. Somebody sang a song about that. And that means we don't know about the cNFT on chain. That's the thing. We cannot do that proof. Let me go small here. That proof here that I get from the read API, we cannot do that on chain. We can't compute that because we don't have that data. The indexers from the read API, they have that data. So all of that we will need to provide within our transaction. So it's gonna be a bloated transaction. I mean, working with cNFTs does have some disadvantages. Like, we need a lot of data to go in such a transfer. Like a bunch of accounts for the proof and then all the creator hash, data hash, all of that stuff. That's just a bunch of data. So it's not going to be easy to transfer several cNFTs in the same transaction. Definitely not as easy as with normal NFTs. Now the easy workaround is to, just get yourself a decompressed NFT, decompress it, work with it, and then you can compress it again later. But that's a little bit cheating. It will work. If you want any program to be able to handle your NFT, you got to decompress it and let the program work with it. But then we don't want to decompress all of our NFTs. We want them to stay compressed. I mean, that's the whole point of, having them compressed in the first place. If we can't work with them, then what's the point of NFTs, right? If you can't transfer them around and use them in programs and whatnot. So we kind of find out how the program can transfer our NFTs, cNFTs. Now, obviously, if I pass in everything into the transaction, then my program has no control, right? I can tell the program, hey, please do that. But then what's the point of the program? I can just do a normal transfer. Or even worse, if the program then also signs for it, right, then you might get to do something that the program doesn't want to do. Or let's put it the other way, an attacker might get the program to do something that you didn't intend your program to do. So somehow we will need to have a representation of our NFT on chain, even though there is no NFT on chain. But there is this asset ID, and I think that's what we're going to refer to. We have the Merkle tree, the tree authority, leaf. Where do I even say which NFT I'm going to transfer? Well, which NFT I transfer comes from a combination of the Merkle tree plus the index on that Merkle tree. So those two things make it unique. If I have those two things, then I'm sure which NFT we're talking about. And I don't even know where the asset ID comes from, but we don't need it. So apparently, I think those are the two things that we'll use. So on chain, if my program, stores which NFT it owns or which it wants to, transfer, looks like we're going to have to make it a combination of Merkle tree, because that's an address that can't change. It's a public key. And then the index inside the Merkle tree makes it uniquely identifiable. Okay. Yeah, let's do that then. Let's make ourselves a program. Send it. There must be a better name for it. cNFT Vault. I don't know. I'm not creative. Let's just do that. We haven't even talked about what we actually do, but this is more of a proof of concept than an actual program. So all I want to be able to do is send a cNFT that is owned by a PDA of my program. I mean, that's the use case, right? Once it's on a PDA, I need the program to be able to send it. Anchor build, and that's going to take a while. So, and because my poor little laptop is not stressed enough, I want a program ID that starts with I like vanity addresses because then it's obvious which one is my program. cNFT. Perfect. Let's take that as my program ID. And we're going to work on definite. So what we can already do is derive a PDA for this program. The program doesn't even need to be deployed yet. So we go full risk. I'm going to make a vault PDA that I just derive from a static seed like cNFT vault and the program ID. And let's run this. And then we get this public key. So in our wallet, we have this just a cNFT that we created earlier, and we can just send it to this guy. So that's the public key that we just derived. Let's just send it. Bye-bye. There's nothing that we need to do there. We don't need to create a token account there. All that we do is change the entry in the Merkle tree to have a different owner now. The address of that PDA. There's nothing at that address yet. Actually, there will never be anything at this address, but my program will be able to sign for that address. Anyway, so we sent that out and it's gone there now. And it's bye. Bye. That was the asset ID. If we were to now take a look at this asset with the read API, then we see that the owner is the 2G QF. It's not frozen, it's not delegated. It has a single owner, this one. Sequence is 5. Aha, so there's something else going on with the sequence. Maybe that's another nonce for when it is moved or when the entire tree is changed. Something like that. I think by now I had 5 interactions with the tree. 2 mints, 3 transfers. Yeah, that makes sense. Maybe that's the sequence. See, we're slowly learning something by making assumptions. Yeah, and that's all that changed. The rest stays the same. We just have a different owner. Now, anchor. You ready yet? Perfect. We managed to build. 3.6 sol. This should hopefully be enough to deploy a program. Build again. And then anchor deploy. And since it's not local, it's gonna take a while. And that's okay. Program doesn't do anything anyway, yet. What do we want the program to do? Well, transfer the NFT back out. I on purpose skipped the sending the NFT into the vault. You will probably want to do this by the program as well, like deposit, such that you can make an account where you remember what to deposit and whatnot. But I first want to get to the core functionality, which is transferring an NFT. So we start with the most important one, which is the withdraw. We're just going to hard code all of it. So let's pretend we had that information of the tree and our leaf, so we know which NFT we want to send. Let's use pubkey from string then. We'll get there. How am I gonna send cNFTs if it takes me an hour to define a static pubkey? Come on. Okay, I mean it's red, but this seems to work. I'm just gonna leave it because after all, that's not how we want to have it anyway. This is what I would get out of the account that stores which NFT I want to send. I cannot work on DevNet because I don't have enough sol. Okay, thank you. Deploying again. Run, just run. Run! Cool. So, let's see. Do we have the withdraw? Yes. And so far it doesn't have anything anyway, and we directly RPC it. Let's see if that would work. Program ID, I can hard code for you. I don't care. Am I just too stupid to create public keys today? Anchor Web 3. There, thank you. Okay, and now, cool, that seems to work. We called our program and it says attempting to send NFT. We can call our program, great. So this is stuff that we just assume we have somewhere. So now to actually the interesting part after an hour of preparation. Let's try and send cNFTs. When we do it from client side, we provide all of this. What's actually hiding behind this? Create bubblegum. So create transfer instruction. So all of those accounts will have to replicate. And then also those remaining accounts. Let's actually have a look how the program looks. So not the JavaScript part, but the program. Maybe it's all in the lib. Yeah, they put it on in the lib. Cool. Transfer. There. Bunch of unchecked accounts. It's all safe. It's all safe. I mean, I guess we will need all of those accounts as well and more. So in my withdraw, all of those accounts, all of those things, we now need to import somehow. Guess I will then need to include that. How do I tell you to import that? There. Solana account compression. Tree config. That's in state of the current one. So here we are inside the Metabrex program library. Bubblegum. And then here in state, there should be the tree config. MPL bubblegum. Also need this. Maybe it's written with a dash. That looks more like it knows what that is now. Okay, we can now also use MPL bubblegum. Here it's written with the underscore. And from here, from state. Yes, state. Tree config. Amazing. Let's see if that builds. Gotta install more stuff because we need the SPL noob, SPL Merkle tree, and all the MPL stuff as well. Well, all the MPL, the bubblegum stuff. So that's all the accounts that we need. Then we'll also use the remaining accounts for the Merkle proof. So the path, the hashes. Then what do we need for data? That's the data that it takes. The root data and creator, all hashes. And then the nonce and the index. So essentially what I'm doing now is build a wrapper for the transfer. That's all. So that I can call the transfer from within the program. I'm just gonna copy that as well. There you go. I tick that. Oh no, could not compile. The global allocator in this crate conflicts with the global allocator in MPL bubblegum. What does that mean? Maybe with the entry point, Anchor has a problem. Okay, let's try that. So we use this with no entry point. Looking bad. Yes! Nice! I love it when stuff works. Progress. No entry point in order not to get conflicts with the global allocator. So I have all the accounts and I have all of the instruction data. Now I just need to do a CPI on the bubblegum program. Good point. Bubblegum program. Do you think they provide the program ID somewhere? Pretty sure they have that in MPL bubblegum ID. I mean, it has a static ID, but that's just a pub key. What do we really need? What is this, for instance? That defines the anchor lang ID, and then ID maps to SPL ID. It's just in declare ID. Oh man, I wish I would know how to use anchor. MPL token metadata. I think I need something like that because I don't find it anywhere. I'm just gonna manually create it myself and I'll put everything into the same file. I'm okay with that. So MPL bubblegum, and that I get from MPL bubblegum ID because MPL bubblegum has the ID, and then I get the pub key from it, so I can use this thing now down here as MPL bubblegum. Yeah, no, maybe. And also we could just use an unchecked account, but that's definitely not as safe. We do want to check that that's the actual bubblegum program that we're calling here. And we could do the checks manually, but while we're using Anchor, might as well use the functionality of Anchor. Just need to find out how that actually works. Yes, nice. Looking good. At least the compiling works. So we have the bubblegum program and we just gotta do a CPI on it. CPI and push in all the data that we want. And we could also pass in the sender as an account. We don't have to do that. We could just derive that because we don't really use it. So here it's a question of compute versus transaction size, like transaction data. And in that case, I even would say I would rather spend some compute than blow up my transaction some more. Wait, no, the tree authority needs to sign. No, the tree authority just needs to sign to create a new one. It would be weird if I need the tree authority to sign if I transfer an NFT. Now that does make sense. It's good. I think it's good. Oh yes, it does. But the bubblegum program actually holds the real tree authority. Because that's the tree config. Ah yeah, here, the tree authority is the tree config. That's what I'm saying. And that's held by the bubblegum. That's not the guy who created the tree, because that's a different one again. He has the authority on the bubblegum. Yeah, oh, this is all a bit complicated, but hey, I think I get it. Just need to wrap your head around it. What else do you do at midnight on a Sunday? I'm getting tired. That's what I do. Now, how to do a CPI in Anchor. We did not go through that module yet. There is a module in the Solana dev course. Just gonna jump ahead a bit. Can't be so difficult. Bubblegum, then bubblegum, then transfer. Haha, haha. That's what we need. Oh, interesting. And then it's the same as here, right? Then we need another, right? We just call that function from the other program. CPI context new with signer, program accounts signer seeds. The program is the context accounts bubblegum program. The accounts, whoa, okay. Oh, the accounts I could get from the, yeah, right, because that struct this transfer thingy here, that has all of the accounts. So hold on, so I do transfer. Let's make it obvious. Let's write MPL bubblegum transfer. And then here I need to put in all of those. Context, accounts, tree authority. That's just a copy exercise. New leaf owner, Merkle tree. Literally just gonna pass all of that through. The only thing I'm not passing through is the bubblegum program, because the bubblegum program I'm having here to call it. So that's all the accounts. Then we need the signers because we do that signed. So here, oh fuck, I need the bump. Wait, I can have the bump. So we just have one, and this one has this plus the context bumps. How was that? There it is. Bumps get, bumps.get, and then the name of the account, which is the vault. Then I think we have everything for the transfer, right? This is getting confusing here. The context has the program, the accounts, and the signer seeds. And then comes the root, okay? Got it. The root is on fire. Root, we just take the root. The data hash, we just take the data hash. The creator hash, we just take the creator hash. Nonce, index, so we just pass all of that through as well. Then we have, yeah, then we're done. And that thing will give us a result, and we're just gonna question mark it. Or actually, you know, we can just return this and then not go okay, but go with what that thing returns. So we return whatever the transfer returns. Okay. I mean, that's it, in my opinion. Do you build, yo? No, damn it. We didn't provide the bump correctly. What if I just write CPI here? Does Anchor build this? Even if my Rust analyzer doesn't find it? I mean, that already looks a lot more like what I want to do, and it doesn't even complain about the CPI. So let's go through this step by step. Can I just put it right here? Oh, we just need to have it there. Wait. That's what I'm missing. I'm missing to say those are references. And S bytes probably does the same thing as I have here with B. So that should be fine. Ah, still red. Eventually I'll get there. It just takes, you know, a while. Much to the annoyance of my editor, as always. Expected struct CPI accounts transfer found MPR bubblegum transfer. Okay, so expected CPI accounts transfer. Sure. I love the error descriptions of Rust in general, because with that error, it's like, hey, just give me that instead of that. And I'm like, okay. But now you have a different problem. You want an account info and not an account. Okay, well, then we just say to account info. And now, this is great code. I love it. There we go. Not even warnings anymore. Amazing. Anchor deploy. Okay, once that is deployed, we can go back to our run and provide the client side with all the relevant information, like all of the accounts that this thing requires. The vault, that is my vault PDA as well. Is my vault PDA always the leaf delegate? Because it must be the leaf owner. So I don't need to provide those as two accounts. So I'm gonna delete this again, take out the vault, but my leaf owner have those seeds. And we don't even have a because we weren't even using the vault anywhere. So now we also need the root data hash and whatnot. And that we get yet again from the read API. And we again need to decode that. Then non-send index, I think is supposed to leave ID. So again, I think I could, save one of those values, but I'm not sure, so I'm keeping them. And then with all of that, we should already almost be able to call it, except it's not gonna work yet because we still need the remaining accounts. But let's try and run it. Let's just try how far we get, because there are gonna be other errors first. There we go. A seeds constraint was violated. That's what we have left. That's what we have right. Caused by tree authority. So the tree authority, I'm not deriving it correctly. Oh, this needs to, of course, be derived with the bubblegum program ID. Bubblegum program. Just take the key from there. Okay. Redeploy. Rebuild and then redeploy. Then let's run this again and see if the accounts are now correct. Okay. We're getting until they're attempting to send. And then we panic because the BPF program panicked. I mean, that might be already because we don't have enough accounts. Can I give you remaining accounts? Remaining accounts. That's perfect, because here I just put the proof path as accounts. So now I put the remaining accounts into my program, but then my program will still not be able to deal with them. So we need to teach the program how to deal with the remaining accounts as well. That might be one of the annoying parts as well here. We are here, and those are our accounts, and we need to provide more. How do I get more accounts into this? Anchor is not made for that. That's the problem. Okay. Normal CPI. Instruction, account infos, signers. Wow, I am impressed. It compiles again. Okay, we have the scaffold now. Just need to provide the right accounts now. Now it's a writing exercise again. Start with the accounts, then the data, and then the account info. Okay, we can do this. And we just take it in the same order as they're here. I mean, this is not going to result in nice programs. If you want to send cNFTs, it's going to be horrible. Tree authority does need to be writable. So new, I assume, means writable, and this thing means signer. This one does need to be writable, and then the remaining accounts already. Let's just leave them for now and still leave out the others. I'd be interested if I get the same error. Now, if I deploy this again and I run my script, do you think I get the same error with the BPF as before? Because essentially it should be doing the same thing now, just that I do a manual CPI and not with Anchor anymore. So what I would expect would be something like this, right? I still get the same error. So I'm assuming that really is because we don't have the correct accounts yet. So the proof path, because we still didn't put the remaining accounts in there. So how do we get the remaining accounts in there? And when are we going to sleep? I don't know. Oh yes, here we panic. I get it, because the vault is not a thing anymore. We put that in the tree authority now. Wait, but that doesn't make sense. The leaf owner, that's it. Fuck, I hate this. I should not have cancelled that. Thank you. There we go. At least you get different errors now. Cross-program invocation with unauthorized signer or writable account. Let's see. It's the tree. Writable privilege escalated. Tree doesn't have writable privilege, so that might actually be in here the issue. No, because we use Anchor. Yeah, no, but it is mutable. Doesn't seem to be writable in here, so maybe it doesn't need to be writable. Read only. An account required by the instruction is missing. That's interesting. Nice, that's the error that we get. Instruction references an unknown account. Because we have all of the accounts the hashes, we pushed them into the accounts here for the instruction, but we have not put them in here as the account infos. So how the hell do we get them in here now? I know where I have them, but I don't know how I can flatten it. My Rust is too rusty. So essentially, the remaining accounts, I want to flatten them. Yes, no, maybe. I don't know. Can you repeat the question? Okay, if that works. Man, that would be fun. Damn it. Alright. It's 4 p.m. I'm gonna give up. This is far from trivial. And I don't understand enough about lifetimes to make it work. After 6 more hours of development, I still couldn't figure it out. So it's not trivial to send cNFTs from a program. That it's not easy. Definitely not easy. So be compassionate with yourself if you don't manage. I'll try to be. And I will see you some other day when I try to complete this. Alright then, welcome back to this Solana tutorial where we will totally manage to send an NFT out of a PDA. I mean, we're getting closer, definitely getting close. I just had to take a little bit of a break to sleep and stuff, and then 2 more days passed, but you know, that just happens. However, I took my problem to the Twitter, and then somebody just told me, yeah, use this. I'm like, okay, if I put that here, let's go back a step. Must be honest, I don't fully understand lifetimes. I get lifetimes. And even Anatoly tweeted to me, dude, you shouldn't have a problem with lifetimes in smart contracts. But obviously I did, because I got that error, right? So there we get this weird, these 2 types are declared with different lifetimes error. And I really couldn't just figure that out. Data from context flows into context. But somebody suggested, instead of just using this context, I put bunch of lifetimes, a lifetime that we don't use, another one, then comes our info, and that's the same one in here. And with that, it should work, except it will tell me that info is an undeclared lifetime. So we're also gonna put that lifetime into here. At least that I know about lifetimes, that I then need to just put it here, and then it should compile. Yes, there we go. It compiled. Isn't that great? Even though we did weird stuff with the account infos push, really, I just don't know an efficient way to put my remaining accounts, so those, into the slice of accounts. So I create myself a temporary vector that I then convert to a slice again. I just somehow need to get the accounts, including the fake accounts in the remaining accounts here, the ones that make up the Merkle proof. But with that all compiling now, let's see if we can send the cNFT out of our PDA. And while that's deploying, let's check out our run script. We do pretty much the same thing as we would do in a normal transfer, except that we additionally add the bubblegum program as an account, but the rest stays the same. The remaining accounts, I still put the entire proof path. The rest is exactly the same as I do with a normal transfer of a cNFT that we did in the previous video. Create transfer instruction. We do pretty much exactly that, except that I now have one additional program in here in the accounts, because I need to call that program through CPI from my program. All that my program is doing in this withdraw instruction is doing a CPI on the bubblegum program with pretty much the same accounts and the same data. This is all just copied over. I'm even imagining that doing this would be easier in a native Rust program than it is in Anchor, because Anchor decodes all of that for me. So I need to encode it again the same way, you know, like this. I mean, it's pretty useless to deserialize and then serialize again, but whatever. I just want to make it work. So yeah, let's see if it works. If we run this, Run! Okay, not good, not looking good. Fallback functions are not supported. So that sounds like we're calling an instruction that doesn't exist. But we are calling our program. We call the cNFT. And it's attempting to send one from here. It's doing the manual CPI call on bubblegum. This is being invoked. And then we get an anchor error. So we don't have the correct instruction hash for the transfer on the program, which is true. Fair point. Yes. Because we didn't provide the data. Because we don't do the MPL bubblegum CPI thing anymore. We don't CPI this. This is the anchor way to do it. But there I didn't. What was the problem here? I didn't manage to get the remaining accounts in there. But if we manually call the CPI, then we need to manually provide the correct discriminator to call the right instruction. So we need to put the discriminator in here. And how do we get that? I mean, I can look at the IDL or I can look at the source code. It doesn't matter. I just need to find out the name. So we have a transfer. It's just called transfer. So I don't remember which letter it was. Yeah, it was the double point, not the hashtag. So now we need a SHA-256 and we hash global double point transfer. Gives us this hash. Then we take the first 8 bytes from this. 1, 2, 3, 4, 5, 6, 7, 8. And we're gonna put that in our discriminator. And while that's building, let's check if this is even correct. When I send the NFT into the PDA, the bubblegum transfer, let's see the instruction data of it. Oh man, you don't display me that instruction data? Oh, Explorer, you're too nice in passing this, that you don't show the raw data. Oh, raw. Huh, I like raw. Instruction data. There, A3, 34, C8 until BA. A3, 34 until BA. It's nice to understand what's happening. It's really, like, I enjoy this. It's cool that I understand those things. Right, it built. Let's deploy. And then we're gonna send the NFT out of the PDA. Come on, we can do it. We can do it. Deploy success. And let's see if the transaction goes through. This is always the exciting part. Will it or will it not work? It will not work. Still fallback. Instruction not found. What else am I doing wrong? Oh, wait. Yeah, of course, I have a string here and it interprets that as byte, individual characters. I need to tell it that this is a hex string, of course. Oh, hex string to bytes. Well, let's add the hex crate then. I don't know if that's necessary. I'm pretty sure you can find some other possibility to decode hex. Or I write that as something different. I could just hard code it as something different. Let's be honest, I could totally do that. So again, I'm not building an efficient program. But there we go, that compiles. Yes. We are getting closer, don't you worry. At some point, this is gonna work. And now, the moment you've all been waiting for. We're gonna send a cNFT from a PDA. I'm gonna say this every time I try until it actually works. It works! It works! Yes! We sent the cNFT from a PDA. Check this out. Check it out now. The transfer, brother. So our program, got a bunch of accounts and a bunch more of accounts because that's all the hashes for the proof with that instruction data. Blah, 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 blah. And it called the bubblegum transfer, which then got the same annoying accounts. The remaining accounts, the 14, the hashes just passed through. And it did the thing. Replace leaf, which is a send. There we go. It worked. We sent a cNFT from a PDA. So the program could do the transfer. Yes. Admittedly, this code is not the cleanest. I'm not saying this is a reference implementation, I'm saying this is an ugly hack on how to do it. Obviously, if you know a little bit of Rust better than me, then you know how to better, do this stuff and this stuff and this stuff without having to create vectors and copy the stuff over and then remove that again. That's all a bit. And yes, it's essentially just a CPI where you call the bubblegum program with the right accounts and the right data. So easy. But yeah, I mean, it just took me 8 hours to figure all this out. 8 hours plus a guy helping me on Twitter. It can be improved by a lot, but that's at least one way to do it. And this is still easy mode. We could still go harder on it when we're like, well, but this was just one NFT. What if I want to send 2 cNFTs with the same transaction? Which, for like an NFT marketplace or like a swap or whatever, that makes sense if you can just send 2 in one transaction. For that, however, we will most likely, unless the trees are super small or the canopies super big, we will probably need to use lookup tables to get all of the accounts in there. Now, is that a topic for another video, or do we also fit that in this one? I mean, it's just 3 p.m. I still have time, right? But I'm gonna undress because I'm getting hot. If we now want to send 2 cNFTs within the same instruction, not much is gonna change, just that we need to copy a lot of stuff and then perform 2 CPIs. Let's copy this for withdraw 2. And here's the problem. It could be from 2 different trees, so we basically need to copy all of the accounts. Only the programs, they stay the same for both of them. So, or actually the leaf owner, in this case, it's gonna be the same one because they will be in the same vault. So some duplicated code, but I guess that's how we gotta do it. And then I'm gonna copy the entire withdraw function. I'm gonna call this one withdraw to cNFTs. Then we're gonna build the same thing with 1 and 2. Actually, thinking of it, I could remove the leaf delegate because I'm just gonna use the owner. Since this is the accounts for the instruction, I do need to put all of them in there though. So for the delegate, I'm just gonna put the owner again, and then the same for number 2. Lots of copy paste. I could probably do better somehow, but I don't know how. So now obviously we will also need to copy all of that stuff. So it's gonna be root 1, data hash 1, creator hash 1, nonce 1, and index 1. And then I will need to find a way to say how long is the first proof and how long is the second proof. It would be sufficient to put in one number, like accounts for proof 1, and then the remaining accounts after that are for proof 2. And I think the easier way for me is to use 2 numbers and say how long is the first proof and how long is the second proof. So I'm aware I could save 1 byte here, but then again, 1 byte. Proof 1 length is a U8. Then I have data 1, and then the same stuff with 2. It's just a lot of copy code. It's really ugly, and there's probably a nicer way to do it, and I wouldn't know how. So I really don't like this. I really don't like how this code looks. I like the software engineer in me is like, cringe. But first make it work, then make it better. And the make it better part is ignored by most people, including me. Now we gotta split those. So we make a mutable index. And if it is smaller than my proof 1 length, then I add them to number 1, else I add them to number 2. So first in the remaining accounts, we put the proof path for NFT 1, and then afterwards, the one for NFT 2. Gotta put them somewhere. And that would continue if you had more NFTs to send. You would put them all in there. Accounts 1, data 1, and account infos 1. And then we do the same for NFT number 2. And that should be pretty much everything for the program. Oh wait, no, we can't return both of that now. We just gotta question mark this. Okay, cool. Does that compile? Value used here after move. Oh, the classic. Classic Rust. So let's not move it. I don't like to move it. We don't like to move it. Building. What else do you do while you wait for it to compile? Bubble gum, bubble gum, bubble gum, bubble. Yeah, done. Okay, that's the program part. The difficulty lies now in the front end. Well, also it's not that difficult. It's just, well, yes, if you have bigger sizes, then it's gonna get difficult. But we start with difficulty level 0. Small trees. So I received this cNFT, the 2G, that's my vault. That's the PDA that I just received this NFT from, this one. So I'm gonna send it back to the same PDA and it's gone. And then I'm gonna get myself another cNFT from another tree that is small. So let's go back to the script with the creating a tree. Create small, not small tree. I'm gonna not have a tree with depth 14, but what's the smallest? Depth 3. I leave the collection the exact same and everything. So that's just another example that you can have several trees that host NFTs from the same collection. There we go. So favk is my new tree. And then I'm gonna mint myself one. Perfect. Yeah. There's now a cNFT in a small tree. Perfect. And we also send that one to the PDA, so to our vault. Just send it and it's gone. And now we're gonna attempt to get out those two cNFTs within the same transaction. So here pretty much everything is gonna stay the same, except that we now do twice as much work. We'll send them both to the same receiver. I'm fine with that. I mean, I could define 2 receivers, but for this example, I don't know, it's not really necessary. You would figure that out by yourself, wouldn't you? Yeah, I guess so. So we have the SIDs. Of course, this is all stuff. I'm gonna put all the things that you need to change up here. We're gonna get 2 assets. Asset number 1, number 2, proof 1. This is literally, I mean, hold on. Give me a break. Can make a function to get all of this? Nah, too lazy. We're gonna just copy code. It doesn't matter. I'm not building good code here. I'm building code that works. Yes, I could do nice functions and stuff, but I mean, this block here, I could. Okay, fine. I'm gonna make a function for this. So how do I get the proof length now? The proof is actually a string array. Proof.length. Gonna be fine. Then I'm just gonna flatten this. I mean, see, if I want to avoid duplicated code, then I do complicated stuff like this, which might also not be understandable for most people. So why do I even do this? But it's always a trade-off between complexity and ease of use. I mean, the cNFTs are definitely more on the complexity level than on the ease of use, but therefore they're less expensive. I'm interested in what problems I'm gonna run into if I first get a transaction size limit or if I first reach a compute limit. We'll see. Cool. Merkle tree 1, owner 1, authority 1, Merkle tree 2. And I think that's all the accounts that I need here. And then I need to add the remaining accounts. And the remaining accounts are now first the proof from NFT 1 and then the proof of NFT 2. So what do you expect is an array of account meta. Just flatten both of those things in here and we're good. And then we put the remaining accounts in here and then we call RPC. And that should work, right? Easy. Easy peasy. Let's see if it's actually that easy. Here's node withdraw 2. It's not gonna work first time. This would be too easy. It worked first time. I'm such a pro at this. Okay, so check this out. We called our program with a bunch of accounts and a bunch of instruction data. And then it performed a bubblegum transfer. And then, scroll, it performed another bubblegum transfer. Nice. I can send 2 NFTs. Admittedly, there was a little bit of cheating because the second send here, so the second transfer, had only a very small proof, 3, because the tree depth is only 3. So I don't need to put a long proof in there. So we're still within transaction size limits. If I had provided 2 of the big ones like here, then I would have probably reached the transaction size limit and it wouldn't have worked. Ooh, and we're also getting close on the compute. 150 of the 200k compute units we've burned. So yeah, it's not a trivial thing that that program is doing here. Yeah, I'm surprised that this worked like on the first try. This is, yeah. Well done, Andy. Well done. Okay. Yeah, let's try it with 2 big ones. So for that, I'm gonna mint myself another normal one. Then I'm gonna send back the big ones as well, just to prove that that actually worked. Here we have 2 NFTs. We just got them out. One from the small tree and one from the normal one. So let's send both of them. Does that actually work? Send both to here. Confirm. Yes, but Solfra does it in 2 transactions, which makes sense. So I've sent them back and I've minted myself another one. Also send this one to the PDA. Bye. And now we try this again with the same code, just different asset ID. And I'm gonna expect this to fail because the transaction size is gonna be too big. It failed. Ha ha ha! Transaction too large. Just about. By 3 bytes, we're too big. We're too big by 3 bytes. Yep. So this ain't working anymore. I mean, those 3 bytes are fairly easy to get out somewhere. I would just need to get rid of one account somehow. Either use a bigger canopy or a canopy at all. I could also, 1 byte is unnecessary here that we already talked about. This last one, we don't actually use this byte. I could probably also get around in making those 2 the same thing, the index and the nonce, because that's usually just the same thing. One is a U64 and one a U32. So I could derive the index from within the nonce. That would work. Then I could make my transaction a bit smaller as well. So there are ways to make the transaction a little bit smaller, but to make it much smaller, to also support, you know, maybe sending 3 NFTs or sending NFTs from a tree that is even bigger than mine, because mine just has a depth of 14 and you can, you know, if you want a million, you want a depth of 20 something. So yeah, we need a way to make it much smaller, the proof, the transaction. And that's a use case for lookup tables, because with lookup tables, we can shrink 32 bytes into 1. Now I did talk about lookup tables before in another video somewhere. And I'm just gonna prove to you that it works by using that, because I totally still know how to do that. Disadvantage, of course, it needs more time and it needs another transaction before, or even several transactions, to put all of the data on chain into the lookup table. Now the question is, what do we put in the lookup table? Well, essentially any account, any of those accounts, or even the proof we could put in lookup tables. For making it work, it would be enough to put those things into a lookup table, because they are always the same, right? The system program, bubblegum program, compression program, lock wrapper, they're always the same. And if I were to save those 4, then it would already be enough for my transaction size now, but not if I have bigger trees. So I would maybe also put the Merkle tree, then the tree authorities, and all of that into a lookup table, which makes it again smaller, the transaction. But even if we have all of those accounts in the lookup table, the transaction might still get too big because so many accounts are just in the proof, represent the proof. So you can also just put those on chain, because we treat those hashes from the proof as if they were accounts. So it will work with lookup tables, is my assumption. I'm gonna prove that to you right now. But I guess I'm gonna cut over the development part, because it's not so interesting watching me sit there for the next 3 hours. So that's the ones that I would definitely put on there. What else would I put on there? Well, essentially you can choose what you put there, right? You can put essentially all of the accounts. Wait, but if we put all of our proof hashes on there, then the instruction is again gonna be too long. Damn it. So we'll have to add more transactions, I guess. Somebody told me I shouldn't call it TX because nobody understands that that's a transaction. But I'm like, come on, dude. It's written right here. It's a transaction. Address lookup table. See if the creation of the lookup tables works. Okay, the creation works. Let's see if the extension also works. Extension also works. Then the second extension will probably also work. And then the transaction will fail anyway because obviously I don't use the lookup table. Extended, and then we're still too big. Okay, cool. That works. Let's use this lookup table. Okay. And once again, we come to the part where we just send transactions. This is gonna take a bit because we first build the lookup table. So this is the lookup table address. Now we create the lookup table. And I don't know if I'm not waiting long enough after the creation because there needs to be some time after the creation before I can actually use it. We'll see. So it is created. Now we're gonna extend it 2 times, once per proof. Extension number 1. And if after extension number 2 it doesn't fail immediately, it does fail immediately, then it would have been good. So the extension has worked, but then send transaction, invalid transaction, transaction address table lookup uses an invalid index. So something seems to just not be up to date here. So how about we just wait and see if that fixes stuff. How long would we wait and where would we wait? Before the table lookup? I mean, yes, I could just do the upper part and then, but I do want to run it all in once because time here is critical. We want to have the most up-to-date data. Okay, so that looks good. A lot of pub keys have been written into that address lookup table. For instance, also I just saw it, the Noob and the system program, bubblegum program, looks good. And can you now also, now that we waited for 30 seconds, can you now also do the transfer with both NFTs from the big tree? No, you cannot. But it's already looking better. A panicked range and index 14 out of range for slice at length 3. Okay. Oh, I have the wrong trees. And then it takes the wrong tree size. But in good news, the instruction was actually simulated and it had the right accounts. So that's great. Perfect. So we just need to update this because now the second tree is also this one because this is also from that tree. And then we try that same thing again. Oh, exciting. We're sending cNFTs with the program, using all the Solana tech that we have to our disposal to get this stuff to work. We needed version transactions to do account lookup tables, and now we need the account lookup tables to do the cNFTs in the programs, and now we're gonna use the cNFTs to build some more stuff. It's all great. But what is this? Is that just a RPC slow error? Try again. Ah, that looks better. So now it's getting exciting again. We extended it once, we extended it twice, and now we wait 30 seconds. Come on. And it's sent. They're sent. We sent the compressed NFTs with lookup tables. Look at it. So check out the bunch of accounts that we have here now. Accounts, and then look at this. Address lookup table, address lookup table, address lookup table, address lookup table, because otherwise we couldn't fit all of those into that transaction. And then we can do actually 2 transfers, number 1 and number 2, each of them with the big proof, with their 14 accounts, or hashes really, that we disguise as accounts. Nice! And so they were both sent. And again, we're getting close to our compute limit, but it still worked. That is how you send compressed NFTs with the program. Now, obviously, with this program that we wrote here, this is just an example, right? First of all, it's not the nicest written program. And secondly, I don't do any like checks, and it's no real use case. I send cNFTs to a PDA and then I use the program to send them out again. I mean, where's the point? The point is to do a proof of concept of how a program would send cNFTs. So you would add stuff like depositing the cNFT somehow. And then you remember who deposited it and which cNFT it was. Because we still live under the assumption that the user provides the correct values here for the index and the account tree. Our program should do checks on that though, to make sure it's the right one. We don't really need to check the proofs and the hashes, because if they don't match, then the transfer won't go through anyway, because you don't compile the correct Merkle root anymore. And then the account compression program will be like, nope, this is not how this works. But we do need to check if it's actually a legal transfer that I skipped here in this proof of concept. So yeah, just be aware of that. Also be aware that yes, stuff can be improved. I'm not a Rust pro. It's more of a look how you could do it and then make it more efficient yourself. Exactly. But hey, we made it work. We made it work. We sent cNFTs, even 2 in 1 transaction. Pretty sweet. I like this. Obviously, this code will be available on GitHub. Check it out and do pull requests if you can improve it. Just to prove that it worked, finish it off, go to our wallet and see there the 2 cNFTs from the big tree. They're both here. They were sent in the same transaction using ALTs, address lookup tables, address table lookup, ALTs. And then this is a ATL. It's funny. All right. Cool. Where do I end it? In front of all those lookups? Or here in front of my amazing code? In front of the CPI. Yeah. All right. Hold tight. It's not easy times that we live in. It's so complicated to get compressed NFTs to work in your program. But it's not actually once you understand it. I mean, took me 10 hours to figure all of that out, but hey, you gotta learn it and then it becomes easy. Well, it's still complex. You still gotta wrap your head around it. This stuff is not trivial. You need to pass in so much data that you even need to use address lookup tables to not blow up your transactions too much. It's, but you gotta do what you gotta do. I mean, the easy way is to just use normal NFTs, but ain't nobody got the money to do that. So it's on us, the devs, to chew more glass such that the people can have their free NFTs. Yeah. All right. And with that said, you can go check out those videos. That's where I did the whole cNFT minting and transfer just from front end. So that's the basis for this video. If you haven't seen that, you should have watched that first. And yeah, if you have any questions, leave them down in the comments in my Discord or on Twitter, and I'll do my best to answer them. And yeah, enjoy working with cNFTs in your Solana programs. Good luck and bye-bye.